Hello, let's talk about the ELS, the Ethernet Loading System from Conair. This is Conair and Rockwell Automation's latest technology in conveying system control. Here we see a couple pictures showing the development of the ELS in Conair's laboratories. The view on the left shows a vacuum receiver interconnected with an ELS control, and on the right we see a test bed that is situated in our lab demonstrating and testing the armor block and armor point components. And if those names sound familiar to you, they should, because they're all components of Rockwell Automation Allen Bradley. And the ELS is actually a control pretty much designed for people that prefer Allen Bradley quality in all of the controls within their plants. The ELS is one of the largest conveying system controls available. It has the capability of controlling 500 vacuum receivers, 96 vacuum pumps, and 1,024 source valves, oftentimes referred to as purge valves. Now the ELS, the Ethernet Loading System, is nearly 100% Allen Bradley Rockwell Automation components. And as we can see here, it's fully distributed and features armor block I/O and armor point I/O as methods of communicating with those devices. But it is not using the old flat media. It is not using DeviceNet, which was Allen Bradley's preferred communications medium in years gone by. And there is no clamps, as we show in the little picture to the right there. There are no clamps down along flat media. What the ELS does do is use Ethernet communications to communicate between those I/O blocks and the control panels in use. Let's take a look at how an ELS control system would be installed. Here we can see an array of vacuum pumps and vacuum receivers and even purge valves. And like they are in most plants, these are distributed around, can be a large area. And so they're located in different areas of the plant. And our job is to control these with one central control medium. The ELS control panel is just that. It is just a control panel housing an Allen Bradley touchscreen. But there's no I/O within the control panel. The I/O is located elsewhere. But up to 6 touchscreens can be interconnected into the same system, all displaying touch-controlled information, all being able to control the system from up to 6 different locations. This is really beneficial to plants that might have a need for control on a mezzanine, or a need for a control in a back room with multiple drying hoppers, a need for control out on the main floor with injection molding machines or extruders, and so on. Up to 6 touch screens can be employed. And here's the way the components of an ELS system could be distributed throughout the plant. We have the controls at either corner there, as you can see, and then we have armor blocks and armor point I/O modules located near the components to be controlled. And all of them connected with those red lines are actually Ethernet communications. So we are sending controls signals from the control panels to each armor block and then looping through those armor blocks or armor points to more armor blocks and armor points and even to more controls. The ways in which the ELS can be connected is actually quite flexible. We can see the control panel in the upper left-hand corner, and as we've discussed, we would have an Ethernet signal going to the first I/O block, and then to the second, and then to the third, and then we actually show an armor point for the next component. But when we need to span great distances, and these distances would be over 200 feet, we can actually employ fiber optics. And so we would go into a copper media to fiber optics converter like we see in the upper right hand corner, and then make that long distance, whether it's between buildings or from one end of the plant to the other, to another fiber optics to copper media converter. And from there we can distribute out to more Ethernet controlled panels and I/O modules. Now this entire system, whether it's using copper media or if it's using fiber optics, is still all industrial Ethernet. Very impervious to noise, very impervious to signal loss. And we see there in the pictures on the left the difference between the plug-in copper media and the fiber optics, which actually use optical signals to move the signal without any loss and without any interference from electrical noise. The ELS system uses proven armor block technology from Allen Bradley. The armor block has been around for years now, but instead of clamping onto that old flat media, this is actually interconnected with Ethernet, as we're showing in this picture. And that armor block has a certain capacity of I/O. But when more capacity is needed for input and output signals, the armor point from Allen Bradley can be employed. And we're showing that at the top and the bottom of these pictures. And then, of course, the final terminations to the actual equipment happens at the armor point or the armor block. And generally, on an ELS system, when we talk about terminations, it's not the old twisted pairs under screws and in connectors and so forth. It's really kind of plug and play connectors, as we're showing in the picture in the center here. These are very industrial, very dust tight, and actually even watertight connections. They plug into the armor block or armor point modules, and then there is a twist ring that actually secures them very solidly. The good news is for maintenance that if something goes wrong with a cable or an armor block or even an armor point, it's all just twist connectors to get it back up and running, to get it replaced and back up and running. Here's a view of what one of these modules might look like when it's fully connected. We can see the armor block in the middle picture there, and the greenish wires at the top would be the Ethernet connections going in and then back out of that module, interconnecting different modules, armor points or armor blocks. The yellow cables in the middle are the actual inputs and outputs from various pieces of equipment, and then that larger yellow plug at the bottom of that picture is the power supply. This is a fully distributed system, and so we can see that the power is also distributed. Each one of these modules has its own power connection. Now, since each module requires power, what Conair does is consolidate the power supplies. So if there is a group of I/O blocks, either blocks or points, then the power supply would be interconnected, kind of as we're showing in that center picture there. So in this particular case, we have a cluster of 3 armor blocks. They're all using a common power supply to consolidate power to each of those. And then, of course, the Ethernet would be connected to those larger circles at the top, and then the inputs and outputs would be connected to the center section where the inputs and outputs are actually connected. The same holds true for armor point. Here we have 2 armor point modules, the larger modules from Allen Bradley, but they are interconnected with a common power supply. Here's a nice view of the ELS at work. Here's a nice little system of a few drying hoppers. We can see a dryer in the distance, 3 vacuum receivers, one on top of each drying hopper, and then we can see a cluster. We can barely see it from here, but we can see a cluster of something going on underneath those drying hoppers, and that's actually an array of purge valves. Now, everything we just talked about, the receivers, the purge valves, and so forth, are all terminating back at that armor block, it looks like an armor point, in the orange square. And that is where the control, the manipulation of the solenoids, the sensors, and so forth, all takes place. And then that would be connected to the rest of the system through a simple Ethernet connection. In fact, this is kind of how Conair packages these systems to make them easy to install and to make them all consolidated for the user. We can see here that we have an armor point, 2 modules of an armor point and a power supply, all mounted to a common plate. And then in this particular installation, that plate has been mounted to a utilities rack that runs through the plant. We can see in the closer view on the bottom there, these things are all ready to go. The only thing that's missing is the actual connection to the loaders or pumps or valves that are going to be connected to that. But that is now implemented into the system. Communication comes to and passes through that armor point and then goes on to the next armor point or armor block or control panel. Truly distributed, fully distributed I/O. Now let's take a little closer look at each of these I/O modules. Now once again, these are off-the-shelf components from Rockwell Automation, Allen Bradley, but Conair configures them to perform certain functions within an ELS system. Let's take a look. First, we have armor blocks built specifically for receivers. This smallest component here, a single armor block, is actually configured for 4 receivers. And these are receivers that have a full complement of feature content, fill sensors, demand sensors, valves, and so forth. And each one of those functions would plug into this I/O block to be operated from the central control. If more control is required, then an armor point can be employed. And Conair has configured this group of armor point components, along with a power supply once again, for 16 receivers. And they would all plug into this particular component. Back to the armor block, here's an armor block that is configured for pumps. And it will actually accommodate all the capabilities of 3 vacuum pumps. We can actually see that in the picture on the far right-hand side. That might be a pump room with 3 vacuum pumps in it, and it's got a single armor block located there to control those pumps. But if there are more pumps present, then an armor point. An armor point is configured for 16 pumps, and it would look something like this. So if we need to control purge valves, we call them here source valves. The armor block is equipped to control up to 8 source valves. Now for Conair systems, these are all simply outputs. And the single armor block has capability for up to 8 outputs for 8 source valves. And this armor block is configured to do that. And once again, if more capacity is required, then an armor point can be employed, and this particular one is configured for 32 purge valves, 32 source valves. Now let's talk a little bit about the plug-and-play aspects of the ELS system. Once again, using these truly proven Allen Bradley Rockwell automation components, we can see the pictures across the top there that actually show these little cable sets being plugged into the I/O. Now once they're plugged in, they have a tightening ring around them, and that actually makes them dust tight and watertight, as we talked about before. Now what Conair likes to do is to use existing componentry on our receivers and so forth, and so we can see in the hand on the left there, we have actually taken the Phoenix connector that is on the Conair receiver, for instance, and converted it into a plug-and-play for the ELS system. This provides a great deal of flexibility and a great deal of serviceability for the maintenance guy. Down along the bottom there, sometimes these are configured into twins. And so one single cable coming out of an I/O block can actually be split into 2 separate outputs, 2 discrete outputs. This one for what Conair refers to as a positive discharge valve on the bottom of a receiver, and for the vacuum loading valve on top of the receiver. Now notice off on the right there we have several pictures of sensors. The nice thing about this plug-and-play system is that many components on the marketplace today actually will receive these cables directly. They're already configured in exactly the same pin configuration as these, and these sensors are an example of that. These kind of connectors can actually be plugged right into the back of those sensors. Very nice. Now taking a closer look at a typical Conair receiver like we're showing in this picture, this can actually be made a little bit lower cost because Conair puts on the side of each receiver that it sells something we call a universal terminal box. This is simply a termination point for all of the sensors, all of the valves, all of the electrical components for that receiver. And those people using these type of receivers probably appreciate that because there is one central plug that plugs that receiver into the electrical system. But now with an ELS, that terminal box is not required because the I/O block that is located a short distance away from it provides those termination points. And we can see these yellow lines indicating cables that would go from each output and each input. The top one going from the vacuum valve solenoid over to a connection on the armor block, and the one on the bottom going from the demand signal sensor on the flange of the receiver going over to the armor block. So you can actually save on purchasing receivers by deleting the universal terminal box. Connections are all direct to the I/O block. So the I/O block not only provides input and output capability, it also provides a localized connection point. Now, does this mean that an otherwise standard Conair receiver is completely reworked for ELS? No, it really doesn't. Here we see in this picture in the upper left-hand corner a standard Conair cable assembly. Now, Conair implemented this type of system years ago to make it easier on servicemen, to make it easier on the parts people, so that the connection, like the coil on the left of that particular cable, is terminated with a Phoenix brand connector. Now, in typical systems, that Phoenix connector would tie right into what we talked about before, the Conair's Universal Terminal Box, or the UTB. On an ELS system, the ELS will come equipped with a mating Phoenix connector, and then that connector will actually tie directly into an ELS I/O, armor block or armor point, making all of these components standard, making them all very easy to use for maintenance people, for implementation, repairs, and so forth. Now, what kind of cables are available to hook up all these inputs and outputs? Well, we can see that with these ELS connection cables. The bag on the left contains a standard cable right from Allen Bradley, and these things come in 5, 10, 20, or 40 meters, which is between 16 and 130 some feet. Conair takes these cables and we terminate them in the necessary way. We can see the one in the middle of the picture there with the orange circle around has actually been terminated into a pair of Phoenix connectors. And then this is the way the system is implemented. This all comes to the user, this all comes to the installer, already made up, already equipped. And we can see the way these might look in the field there on the right. We have a vacuum pump, and we've got a couple signals with yellow cables going back to the armor block. Same thing with the receiver. We saw this before. The input from the base of the receiver is going over to an input on the armor block and an output. The vacuum solenoid from the receiver is going on to an output on the armor block I/O module. Let's take a couple of looks at some screenshots from the ELS. Now, those of you that are familiar with Conair products might recognize this screen. It's very familiar, since Conair's other control platform, the FLX, looks exactly the same. They both have their place in the marketplace, and very similar functions, and luckily very, very similar navigation. This familiar screen has a help button at the top and then a column of very popular buttons to allow you to navigate very, very swiftly to systems, pumps, more information, maintenance, and even security. You can see that key there towards the top of that column there. That is to block out unqualified changes being made to the system. If we navigate not too far down into the system and take a look at a specific vacuum receiver, here we see actually a picture of a vacuum receiver, and this particular one is equipped with a ratio proportioning valve on it. In this view, we can see the vacuum pump that it's connected to. In its location, we can see a purge valve that it's also located to. Once again, note the familiar column of common buttons on the right-hand side, including the home button at the bottom. So if you ever get lost, you simply press the home button and start over again. But on the screen, we can see the load time setting, the discharge time settings. We can see a button towards the top there that actually turns us, I should say not turns it on and off, but actually enables or disables this receiver. A lot of information here, and really the only difference between this control face and one of our other popular controls, the FLX, would be the identity of this loader in the numerical reference along the top there. This particular one is loader 145-02. And what that is its actual location within an armor block or an armor point within the system. Very, very convenient, very, very reassuring to maintenance people to know exactly where they are and how things are connected. Now, if we press that ever-present question mark at the top of the screen on any of those previous screens, it will take us to some help screens, very much like this one right here. And what this is an actual onboard explanation of all the wiring points on the armor block. And so this tells us exactly which port does what and how it communicates back to the central control. Once again, very reassuring for maintenance people to do very rapid troubleshooting, and also if they're hooking up something new to know exactly where to tie it in. And there's almost an identical screen for the armor point. So this would show an explanation of the inputs and outputs, and once again provide great serviceability for the maintenance people. Now here's a feature available on the home screen of the ELS, and this is unlike anything else in the marketplace except for Conair's ControlWorks control panel. This is a feature we call QuickFind. And because the ELS system has such a very, very large capability, up to 500 receivers, there might be a little bit of difficulty or a little bit of time involved in actually seeking out the particular component that a maintenance guy or an operations guy might want to find in his system. Well, we make that very simple with this QuickFind feature. So right there we have a little compass, and if you press that compass, you'll come to a preloaded image of your choice. Now in this particular case we're showing a little bit of a plant layout there, and it might be somebody's actual plant. But what Conair does with the QuickFind feature is to break up that image into quadrants, as you can see marked on the screen. And those quadrants can be populated in the software with any components you wish to use as an indicator. Now this might be a geographical reference, it might be the actual layout of the plant floor, it might be a flow diagram showing the way the material flows or even the way the customer's product flows through the shop. Or it might be people. Each of these quadrants could be a person, and all the components that are under that person's control might pop up. It's really, really very broad in the way it can be used. The most common is something like this, like a floor plan that would show the components in a geographical area, making it very, very familiar and very specific to the actual location where the ELS is located. And because this is a touch screen, we can actually just walk up and touch an area of this screen. Let's press on quadrant number 3 and see what happens. A dialog box appears and it said, what do you want to look at in quadrant 3? Do you want to look at pumps or do you want to look at the vacuum loaders? Now once again, this is entirely up to the user's programming, and of course Conair would program this for you, but you might have a singular component, you might have a group of components. In this particular dialog box it has a group of components in there, but you can use this as a way of zeroing in, a way of drilling down into your system to look at exactly what you want to look at with just a few keystrokes. So the QuickFind feature is actually a top-level navigation control that allows users to lay out their own control paths. How do you want to organize your plant? How do you want your people to look at your system? You can organize systems by location, function, type, even personnel. So these quadrants can contain whatever information you want to see there. They could include a floor plan or a flow schematic for visual navigation. So a very convenient method. We call it QuickFind, and it's a very, very simple means to an end, understood by virtually anybody on the shop floor. We invite you to take a look at the literature on the ELS conveying system control. It's a 4-page brochure that has many of the images that we just saw in this slideshow. It's all available at conairgroup.com under the conveying product line. And if you are ready to take a closer look at this type of a system, give Doug Brewster a call. There's his key information right there. Doug is the Conveying Systems Product Manager, and Doug likes to get his arms around these types of systems. And note that when you input information into the inquiry for this, Conair would love to lay out a floor plan that would show the location of each armor block, each armor point, each pump, each receiver, each valve, and including all the cable sets that would be necessary to connect this system, the location of control panels, and so forth. If you can't reach Doug, certainly feel free to talk to your local Conair representative, your Conair regional manager, or just give us a call at the Conair Group at 724-584-5500. And of course, you can always read more about it at theconairgroup.com. It's been our pleasure to tell you this about the ELS Ethernet loading system from Conair. Thank you for your time and attention.